Hi everyone, welcome back. In this video, we are going to see few different ways of how we can create a dissolving shader or an erosion shader, like you can see on the screen. Let's get into it. There are a few different ways we can create that shader inside our material. Let's go one by one. The first thing we are going to do is add a material, create a material. I am just creating a normal material, which will be value erosion. So our first setup will be based upon values of any textures we are providing. Okay, so I'll just go into it, created a value erosion. So first of all, I am just changing it to translucent. You can keep it anywhere you want. Basically, what we need is either opacity mask or opacity. So if you're using a mask material, you need to connect all your the final output of the erosion shader into the opacity mask. Or if you're using translucent, we can plug that into opacity. Cool. So I am just changing into unlit so that I don't have to care about anything else. Making it clean. Okay. So first thing what we need to do is take a noise. Okay. So I'm going to use a texture sample and I'm going to use a noise. So let's see, I will just increase the size. I'm going to use this noise pattern. Okay, and I'll just connect the opacity. So you can see right now what is the default opacity of our texture, the noise pattern we are providing. I am just changing it color as well. I had just put a color and I can just use this opacity. I can use a multiplier node to just check if it is working or not. So by 1 it is this, 0.5 if I do it's a little translucent, 0 completely gone, right? So it's working, we know that, correct? So now what we need to do is to basically subtract something from the texture which we have provided, like the noise texture, right? So I'm going to use a subtract node and I'll just use a value. So you can either hold on to 1 on your keyboard and click, so it will create a float parameter for you. It won't be a parameter, it will be a float. We can convert it to parameter as well, right? Or if you keep pressing S on your keyboard and then press, so it will create a parameter for you. So just to keep that in mind. 1 is just the float and S is float parameter. You can right click and promote to parameter as well. I'm going to rename it erosion value. Let's keep it 0.5 as of now. Okay. And I'll just connect it here. Right. So you can see. So now this value is based upon whatever our texture is. So if I change the texture to something like this, you can see, because these textures has different values of it, right? Different values of white and black, correct? I'm going to keep using the previous texture just to explain it better. So right now you can see this we can control, this parameter we can control. I'm just making it 1. So you can see now it's completely gone. So whatever our value was of the noise pattern, we have subtracted 1 from it. So basically that means overall texture is gone. And if I put 0, so nothing is gone. So let's keep it at 0.5. You can see this. Or we can use a debug time node for now. Debug time sign. What it will do is it will keep evaluating on 0 to 1. It will keep fluctuating. I need to turn on real-time viewport. So now you can see better. Correct. Change this color to something darker. So now you can see it's not completely going towards the texture, and we want complete 0 to 1. So first, if you have like too much values in your texture, like too much difference of black and white and grays, we can use a saturate node, which will basically clamp your values to 0 and 1. So if I do that, it basically clamped all my values to 0 and 1. Okay. It depends, again, it depends on the texture which we are using. So I'm just using this for now. I don't want to use saturate. Okay, and now what we need to do is to control this edge, which is the softness of this edge, right? How much softer we want or how much harder we want. A very basic thing we can do is to shut it down with seal, so there will be no softness on it. So what seal will do is it will basically round off your values to the next integer. So it won't have any softer edges. So you can now completely see this. It's completely coming back from 0 to 1. But let's say now we want to control the softness of it and we don't want to use the seal node. So what we need to do is to add a divide node and bring it to opacity. Right now the default value is 2 in the divide node. I can make it 1. You can check the softness. I will reduce this speed. Just putting this here for now. You can see better. Now you can see better, right? How the edges of our texture is controlled. And I can promote this to parameter as well and name it softness. If I don't want 0, so if I don't want anything, like not any softness around, I can keep this. Or if I want something, I can put values on that. Now if you see, it basically does not gradually increase the edges. Like we want to fade off just the edges, not the entire texture, right? So we can keep a saturate node as well at the end and just put it there. This a little bit. You see, this is how we can create a simple value-based erosion. I'll just delete this saturate for now. Keep the softness at 0.5. Let's save. Point 0.1. I like this much better. And now, instead of debug time node, we can make a parameter of the actual value we want, which will basically we can animate inside the blueprints or sequencer or Niagara. For Niagara, we need to create a dynamic material parameter. So these are dynamic parameters, and we have to name it erosion, and keep a default value of whatever we want. Let's say we don't want anything right now. So I'll put 0 and we can keep this. So there will be nothing, but if I increase the value to 1, not 1, 0.5, you can see it's working. So yeah, You don't need dynamic parameter, time sign, seed, anything. So this is a very simple effect which we can use, and we can animate it over time anywhere. So it doesn't matter whatever your texture are, emissive color, or base color, or anything. You can put your final thing in the opacity and either multiply it or add it, whatever you want to do, right? So for the second method, what I want now is to create an edge. So we can give it a different color. Edge offset we can give it, and we can control the thickness of the edge from where it is disintegrating or eroding away. We can use that effect in like disintegration as well, right? So that's why disintegrating. So let's see, we will create the another one now. For this second method, what we want is to get an edge on the erosion part and the control over its edges, like how thick it can be. So I'm going to create a material underscore erosion edge. You can name it whatever you want. So last time I showed it on a translucent material. So this time I want to show it on a mask material. Let's say I'll keep it unlit for now. You can keep lit as well. There's no problem. Yep, I'll keep this lit. And now we are going to see this material and put it into opacity mask, correct? So let's take a noise. The base method is same. We will take a simple noise. Whatever our, let's take the previous one only. Noise underscore was something like this. Yes. I'm going to take this noise, take a subtract node, put a debug time sign just to see, take a saturate node and take a seal node, and I'll put it in the opacity mask. Now you can see how our material behaves. I'm going to turn on the environment as well so you can see it better. Save it. Now we need an offset for this. So what we can do is to basically copy and offset it by a certain time, or we can subtract the values as well. So I'm going to make another thing, which is take another subtract. We're doing the same thing here. We're going to take another subtract, and basically we will add something on our original offset value. So this currently is our debug time sign, but if we create a parameter which will be our offset value or erosion value, we will put all these here, correct? So now what I am doing is basically adding something on this, and this will be our edge thickness. Correct. I will just make it 0.1 for now and will subtract it. So I have offsetted the original value of our erosion or offset value. I have added something on that and created another stream of the same texture, right? So we have a subtract by default, which is taking the original offset value, and then added on top of that is another value, and I have subtracted the same texture, correct? So this will be our edge thickness. Now, if we multiply this by some value, it will create our edge offset. Promote this edge offset. Make it 5 for now. Keep it like this. Okay. Now I'm going to take another saturate so that our both of our values are there. I'm going to make another subtract node here. So now what I can do is I can multiply this with a particular color. Pick a color which is this, and I'm going to increase its value so it looks brightened. And I am using this color. So now our this final node becomes our emissive color or base color, in whichever you want to put it. Correct? Now you can see how much of a difference it makes. If let's see if our values work, but right now I want it to be a little bit slow. You can see there is some weird thing going on. This is not properly working, correct? So what we can do is to after this subtract node, we can add a seal node so that it doesn't give you these softer values. Now it's much better. So let's see if our thickness values works. If I make it 0.03, our thickness of our edge has become more lesser over time, right? And our offset, if I make it 10, offset is working. Offset works basically as a multiplier because we have multiplied it. So you can see a very drastic difference between 1 and 2 as well. So just to keep in mind, very lower values will work. So 1.5 might work. And if you want a very thin line, right? Save this. You can rearrange this better. You don't want a direct connection throwing off because it basically builds up when you are doing it for a character or anything else. So you can basically make a named reroute and serve color. What this will do is we can now call this reroute node to anywhere in our material graph. So if I turn this off and if I just right click, it will already be on top. So we can use this emissive color and put it inside here and just save it. You can create a material function of this as well. Instead of just putting it here inside a material, we can create this as a whole material function. And we can use that emissive color here as well. I'll just apply this on our very basic mesh. Let's say we'll apply this on a third person mannequin. I don't know why it's taking time, but that's cool. And now I can take this material and I can put the whole material. I don't want to drag it. I can just this and this. You can see much better how this is working. Now let's just create a material function which we can use in any of the characters or any of the materials which are there, right? So that we don't have to always recreate it again and again, correct? So first of all, it's the same process. We can just copy the whole thing and create inputs there, but I'm gonna recreate it so you can follow along as well. I'm going to create a material function inside material function. I generally keep them under a utilities folder, or you can create a folder inside materials under a name of functions so that you can find it better, right? I'll just move it here, rename it mf, which will be material function. Let's make it erosion. Okay. Just go inside that. So right now we have nothing, which is empty. So the very first thing we will take is a texture sample. Okay. And we are going to take texture coordinate. So if we ever need to make our texture basically more tileable, we can make it here. We can change the tiling of that. So I am going to make an input function input which will be a scalar parameter. So functions put scalar, and we can use preview value as default. I'm going to name it tiling. Okay, that will be great. I can put it here. For noise, I can basically supply the base noise, whatever it is. I guess it was named noise 19. Correct. Here, I can convert this to parameter as well, but right now I don't want to because I'm going to create an input which will be texture. I'm going to create an input which will be our texture 2D. Yes. And yeah, I will apply this here. In a moment, when we apply this inside the material, you will get to know what are all these inputs. The next thing we want to do is to build the same thing which we did here inside our materials, inside our material function. I'm going to take a saturate node, even if it's not needed, but we can keep it. Saturate, and then I'm going to take an input which will be our erosion input. We can turn on use preview value as default. So it will be our erosion, and we want to subtract. And sometimes these values get out of hand, and by mistake we can do something, but we don't want to go outside of bounds of 0 to 1. So I will just saturate it as well. And put it here. Saturate. We don't need this anyways because we are adding after it. So I'll just delete this for now. And we were going to subtract, right, and add into our offset values. So add an input which was of thickness, which will be a scalar value, not a vector. Even the erosion will also be a scalar value. Just keep that in mind. Thickness. So the preview value right now is scalar, so it will take whatever we are going to give here. So I am putting 0.03 as default. That will be better, and we subtract it and multiply to get our another input, which will be our edge offset, and I'm making it 2 and a scalar value. Saturate, we needed to subtract it. Saturate, subtract it, and we can put a serial note here. So this will be our main output, and we can rename it to opacity so that we know we will be putting this into the opacity or opacity mask. And for this, I'll just multiply it with a color. By default, I'll just keep it black. That will be fine because we are giving it as an input, so we can control it inside the material. And I am going to make a function output, which will be our emissive. This is it, I guess. Just checking all the inputs are proper. So for color, we have vector 3, edge offset scalar, edge thickness scalar, erosion scalar, texture 2D layer scalar, tiling scalar, and texture coordinate. Correct. And I'm going to apply and save it. Now what I'm gonna do is call this function inside material. So let's put it here itself. I need to copy this materials. I am duplicating this underscore first. I'm going to delete everything else here. Okay, now we have nothing currently. I'm going to call mf underscore. So now you can see all our material functions which exist in this project are here, right? But we can't find ours, which was mf erosion. I have saved it as well. That is because we need to turn one option on, which is when you don't have anything selected, you will get details of the material function, and we need to change this option to expose to library. Okay. Once we save this and go here and search for mf underscore erosion, you can see we have our erosion. And now we have our input texture, the erosion value, the edge thickness, the edge offset. We haven't renamed the color to proper naming, so we need to do that as well. So I'm going to go here and name it properly color. Save it. Save this function test as well. Let's see how we can use this function. So we have a texture here. So I can use a texture object instead of a texture sample because it's sampling out inside our function itself, right? So I'm going to take this texture object and select our noise. Noise underscore thing. I want to recreate the same, so I'm just selecting that particular noise. So our erosion value, I can put promote to parameter. That will be 0.5. Just to check, putting this in emissive and this in opacity. so that we don't lose any of our stuff. I'm going to material as mask default, that is fine. And we need to define our edge thickness as well. So, 3 cool, and our edge offset will be something 10. Our color, I'm going to this is vector 3 and we were doing vector 4. We will need so I'm just changing it to vector 4 as well. The color behave properly, but let's see. So let's see what we did wrong here. Multiply, saturated it, subtract the saturate, seal, multiply, and this. That is fine. And this is also fine. Then why this is not working? Have our input textures selected. I'm going to select, okay, texture is already selected. Here, subtract, rate, add into this, but we are subtracting it from the itself, from the value. So we need to subtract it from the channel. This was the main thing which we need to subtract it from here, from the texture. This one I did wrong. Save here. I don't know why this is not updating, but I will just import it again. See, now it becomes fine. Thickness, set, color. I guess styling we have put already to 0. So we need to change the tiling to 1 as by default. Right? Save it. This into a passive. Erosion is currently, I'll just delete this. I will make it 0.5. So now you can see much better. Color is 10, but then I guess the seal is not working anymore. So I have to go and check seal option. So we haven't provided the seal option which was there when we before we multiply the original color, we put a seal node so that we don't get the faded off edge, right? So we need to put a seal node here as well. Now you can see our function works better like this. So let's say we want to animate erosion over time. Okay. I'm going to, you can see it properly. So I'll just make it here, the details panel. You can see much better. I'm going to select this mesh and I'm going to select our function test, which we were doing with the function, right? MFL function test. And I need to close everything else. Yes, I want to save it. And I'm going to put this material here, function test. Okay. And let's put it into a sequencer first. I'm going to create another folder. So we can name it sequencer erosion. We're going to put our skeletal mesh here. I think it will import with all our control rigs and all. We don't need any control rigs right now, so I'm going to just delete it. Animation also we don't need. I have deleted everything. So right now what we can do is we can import the skeletal mesh component, put the skeletal mesh component and use all our slots is to, we can import the material here, and from the material we can use all the parameters which we have given inside the material. But then if you have a character which has a lot of slots for material, you can't obviously go and keep on creating erosion parameter for every slot and animating it, right? So what we need to do is to create a global parameter for erosion. So I'm going to delete the skeletal mesh component, which I don't need right now. To the content browser and the utilities, I'm going to create something called material parameter collection, which basically will allow us to use this all the parameter as a global value. MPC, which is material parameter collection global. We can use these parameters in every material parameter, which is scalar, and I'm going to make it erosion. Just name it erosion. By default, I am keeping it 0. And now we need to put that inside our material. Okay. So I'm going to search for parameter collection. So it will by default automatically select whatever is selected in your content browser. So I'm going here and selecting erosion. By default value is 0. So if I supply it here and apply, I connect this here. Connect this here and apply. See, our thing went to 0. Our mesh erosion, it's not eroding anymore. So what we need to do here, we need to add a material parameter collection track and use MPC global, which we have already done. And now you remember we have 2 slots here, both have the same material, and we are using parameter collection inside the material. So whenever we animate here, it should animate on both of the slots, correct? So now I have imported MPC global. I'm going to add erosion. So at 0, you can see it's 0. And by 60, I want it to be 1. So it should completely erode away. So now if I play this, you can see it's eroding. Correct. There's one thing to keep in mind, which is if you change this parameter name, which will be global, let's say I change it now and save it. Inside the material, it will already be erosion. So we need to set it to global erosion first of all, because saving that doesn't work. Sometimes it works, sometimes it doesn't. I don't know what's the issue with it. And the important part is in the sequencer. it won't update. I have tried multiple ways to updating it, but it doesn't update automatically. So we have to go and make it global erosion. The one good thing is you can copy all those things. And first delete this key, copy all those keys from the previous one. Control V does the work, but yeah, I can delete this. You can see the global erosion works. It's a very good thing that it can work with animation as well, because we have selected a skeletal mesh, so it doesn't matter if we provide any animation to it. Let's say run. It's just going to take time, which is fine. Late, it will automatically starts doing its thing. Now you can use Niagara particles with this and start emitting particles while it's eroding, so it looks like it's disintegrating into something, right? You can design your simulations according to that. I mostly use it for disintegrating effects, or sometimes if you want to use it for paper burning kind of effect or something burning, right? A cloth or anything. So it basically slowly you want to deteriorate something. Mostly I use for all those kind of effects. It is very useful. You should try using this method in your own project. It's super cheap as well. Yeah, thank you.